What is up, everybody? Welcome to Advanced TypeScript Welcome to Advanced TypeScript with me, Matt Pocock. Spam in chat if you're here. Hello to Jay. Hello to Bishwajit, if I'm saying your name correctly. Hello to Victory. I'm so excited to be doing this. I haven't really advertised this properly. Haven't really spoken on Twitter about this properly, but I do love me some streaming and I love me some TypeScript, and we're going to combine the both today. And I'm going to stay on for about an hour, I think, and I'm going to answer any of your questions that you have, whether it be like basic stuff about TypeScript, whether it be advanced stuff about, whether you don't understand something from the docs and you need some questions answered. And we're going to look at some cool stuff too. The first thing I wanted to talk about was, or in fact, why don't we chill out here for a minute, just let people file in. Let's see. So, in fact, why don't we, as a little warm-up, hey Bishwajit, let's take a type challenge from the type challenges repo, and let's just crack through it together. The one I want to look at first, I think, is there's a bunch here, right? Like we could do push, unshift parameters. Let's see if we can go concat here. Okay, cool. Implement. So for those who haven't done type challenges before, haven't seen type challenges, implement the JavaScript array.concat function in the type system. The type takes 2 arguments. Output should be a new array that includes inputs in left to right order. All right, so let's take the challenge. You press take the challenge. I'm going to take all this stuff and I'm going to put it over in my code editor here. Let's see, challenge1.ts. And you should see, in fact, I just need to install yarn add type challenges utils. And let's get this going. So we have type challenges utils, or it should be here, and we should be seeing some nice little TypeScript errors coming up. Okay, so equal concat, yeah, and in fact we have our concat up here. So the idea of this is you basically need to solve this code in order for it to pass these test cases. So we have expect equal this here. And concat takes 2 parameters, as you can see here. So I really hate the way they name this. Like this should be t first param and t second param. And what we need to do is push those 2 together. So this is going to need some, hey Valio, this is going to need some stuff that I'm not very good at, which is actually like pushing 2 arrays together. So we know that this one has always got to extend any like this, and this second param has got to extend any like this too. So these extends clauses basically mean that the things that we pass into this first param have to extend this. So if we say like type whatever equals concat, I don't know, 1 and 2, then this is going to give us an error because it doesn't satisfy the constraint any array. So we need to pass in arrays there. So what I think we need to do then, we can just do this, right? We can just return first param, or t first param. Yeah, thank you GitHub Copilot, you read my mind. So you can just spread those in. So that little bit of syntax there, what it's basically doing is saying, okay, we know that this is any up here. And in fact, if I remove that constraint, yeah, we're going to get an error there. It's basically saying create a new tuple out of all of the pieces there. So all of these test cases are passing. I appear to have just stumbled on the result, which is quite fun. So is there anything that I'm missing here? I guess could this be typed as array differently or something? And that needs to be array any, of course. Array any. But I guess that's equivalent to what I just wrote. Well, that was pretty easy. Damn. So yeah, this syntax may seem unfamiliar. Let's just break it down even a little bit more. We've got our generic type up here, which is kind of like a function which takes 2 generic arguments. And then down here, this is it being called, essentially. And here we know that the first param is going to extend in any array, so it's going to be an array of something, and the second param is going to be an array of something as well. Then we take t first param here and we spread it in to a new array that we just created there. And then we do the same thing with t second param. Everything here is necessary, I think. I'm not sure I could make this any more terse. For instance, if I remove this, then it says it must be an array type. And the only way that you can constrain it to be an array type, I suppose you could do something like t first param extend any like this and then do it, otherwise do never, which is a conditional check. This is one way of doing it, but really it's just less code to constrain it at the generic level. Yeah, Bishwidget, I picked a good one here. Just kind of stumbled on the answer. I thought it was going to be harder than this. Damn. But this is how I guess we get our Concat working. One really cool thing you can do with the type challenges, you can actually check out other people's results too. So if I just check in here, I can go to check out solutions and see what solutions other people provided. So let's say there's this one here. Yeah, there we go. Exactly the same one as ours. Pretty good. So this is a variadic tuple, Bishwidget is saying. So if I Google variadic tuple, and let's see if that's in the docs anywhere. Yeah, here we go. Variadic tuple types, playground example. Let's check this out. Consider a function in JavaScript called Concat. Here we go. Let's see. I'm going to try and understand this later, I think. I think this change enables a lot of the sort of tail stuff and the clever stuff we're actually going to look at in a minute with someone else's contribution we're going to look at. Duine Eduarda, yes, this will be available later. You can watch the stream now live with me, or it will just be available as a video on this YouTube channel. So if you want to subscribe to this, then you can check out all of the videos at your leisure. Let's do another one. That one was a bit easy. So let's do, we done Concat. Let's now go for a push. Oh no, in fact, I think I fancy doing an includes there. So this is the next one after Concat. And let's take the challenge, copy this over into our editor here. So we've got challenge 1, let's go challenge 2. Okie dokie, a lot more going on here. So, includes. So this is a good one here. We're expecting the result of this includes to equal true. So whatever we return from this function, it needs to be either true or false. And what we've got is a tuple with various different members. And we basically need to check to see if something in there matches this. So it's like a JavaScript includes function or a find or something like that. So let's see. It's obviously not going to work if we just cheat and put Boolean, right? Because actually what's returned from this is it should be either true or false instead of just a Boolean. God, there's loads of cases here. So it should be like an object. Yeah, we need to check for like read-only stuff as well. Wow. Null, undefined should be checked out. Okay, so I feel like this might be a more complex one, or it might be relatively simple and we can just rely on TypeScript to figure it out. So when you're checking something, obviously we're going to need a conditional type somewhere. And I think what I'm tempted to do is, first of all, we need to take T, so which is the T array, and check for T item as well. So what we're likely going to need to do is, first of all, get a union of all the possible types inside T array. So we need to know, okay, whether it's cars, is AC/DC, WAMU, Santana. Santana, great shout. So what I'm going to start with is a T array number. Now T array number, that's basically going to say, okay, it's either going to be, so if I go like type example equals cars, yeah, this one, and then type member equals example, and then number. So what this is going to do is it's going to take all of that and it's going to turn it into a union type. So it's a union of all the possible members. And now what I can do is I can say, if that extends T item, I need to work this out in my head, true, false. I might need to switch that around. So here, for instance, yeah, okay, it's getting the false working, which is nice, but then maybe it's just returning false for all of them. Extends is funny. Sup, Angelo, how you doing? Because like extends sort of works differently from how you think it's going to. And I'm never quite intuitively sure which way to put it round, because we're basically comparing like this versus type, just say cars, for instance, equals cars. So like this compared to the one below it, which one extends the other? Like whichever way we get it round, it's going to be interesting. So if we say, let's go type includes, and I'm trying to extract this out of this top level bit here because it's hard to introspect this stuff really. So let's go for member includes cars, which is going to be a Boolean of some kind. And we're going to go with member extends cars, true, false. Okay, so member extends cars is false because this doesn't include that. So what happens if I go cars extends member? This is what I'm thinking. So now cars does extend member because member is, I guess, like wider than cars. Bishwaji, you're saying, yeah, we have a reverse relation here, which means that you're basically checking if, so I'm trying to work out which is the wider one and which is the narrow one. I think the wider one is supposed to go afterwards. I think. Yeah, so the union type that you're checking against is supposed to be the thing that you're extending from. And so I read an article about this, but I can't just bring it to mind properly. So if I change this to like wowie or whatever, then member includes cars is going to be false. So in theory, what I need to do, yeah, okay, A extends B is A is assignable to B. There we go. Okay, so this means that what we can do, let me just bring this out even more. Type wow equals, for some reason I always choose wow as my thing, I don't know why. We can say that, let's imagine that we have TypeScript, you can have like literal types, or you can have the types that represent sort of broader types. So for instance, string here. Let's say string extends any, which is true or false, okay. So what we're checking here is we're checking whether this condition is true. Wow is going to return true if it is true, and currently it is true. So we can check if string extends string, which is kind of like saying 1 triple equals 1. But does string extend a literal string here? So no, it doesn't. That's because you can't assign this to this. Let me just take some water on. I'm talking a bit too much. So what this means though is we can swap this around, because you can actually pass 1, 2, 3 to something that expects a string. So if we have a function down here which is like const myfunc equals this, then we can go param is a string, and we can pass it myfunc 1, 2, 3 like this, and that works. Whereas if this said 1, 2, 3 and we passed it a string, so let's say we pass it 2, 3, 4 as string, so we're passing it directly as string, you can't assign that to 1, 2, 3. So this is the check that we're doing. So we're checking if we could pass 1, 2, 3 in a slot that expects string. That makes a lot of sense. So we've got wow, that's done. So that means up here, we need to check if we could pass t-item into a slot that expects t-array number. Boom. And so, okay, now type false does not satisfy the constraint true. So I don't know what's happening here in terms of like, so extends that, a that. This is intriguing. So what happens when you have an array of just like this? Because, because this relation here, it basically seems to be includes Boolean. So this is where I'm sort of tripping up a little bit, because I'm unsure about where we're going from here. So includes a Boolean false. I wonder if this, yeah, let's look at each of these in turn. So the object one sort of scares me a little bit, so I'm going to drop that for a bit. let's imagine that we have this includes 1 or 2. Oh God. T item extends this, true, false. I think, you know what? I'm going to give up. I'm going to see what other people are doing. This is the moment when I've kind of like reached the limit of my patience here, and I'm going to cheat. So let's see this. Okay. There's some interesting stuff here. Let's look at this solution. Comment that out and put that here. Okay, so all passes, which is good. So there's some equal XU extends true. So it's relying on the type from there, which seems like a little bit of a cheat. So it's saying, okay, equal extends true, then true. That seems a bit funky. Okay, I don't really like that one. Let's see if there's one here. Okay, that's doing the same trick. Anything here that doesn't do the same trick? I figured this would work. Yeah, this is the same, basically the same as my answer, but it doesn't work, right? Unless I'm sort of on the wrong version of TypeScript or something similar. Let's check if this does actually work in the piece. So take the challenge, stick it on here. Yeah, so I'm getting the same error, so that one doesn't work. Check out solutions. Let's go. This seems like a hard one. A lot of people are finding this tricky. This equal one is the same stuff, right? How are people just... is this cheating? Like, this seems like cheating to me. You know? I'm not sure if you can use like part of the question in your answer. Okay, so one... Yeah, that's not right. So no one seems to have got this right. Or at least in my book. I can't find one that... I'm looking at all the English ones, but maybe there's one here. Yeah, so they've implemented an equal there. Okay, I see. So they're using something... They're basically using like a custom equal, which I guess makes sense. And what's going on here is there's some cool stuff. So let's have a look into here and let's see what's going on. So at least they are kind of using the same stuff, but they're using a custom equality thing. So my equal, let's pull that in. There is some real hacky stuff going on here too. Okay. So the includes here, what's happening is they've basically got the same constraints as us. They've said, okay, there's a read-only any array here, or there's a U here. And the U is the second param they're passing in. And first, what they do is I'm just going to rename this with this. So T, first param. And what they do is they first check if it's, they take the first member of the array and then check if it's true. And you can then sort of infer the rest. So this rest, it's like you've got the first member of the array and then you've got the rest of it that comes afterwards. So almost acting like a reduce in JavaScript. Then you compare if the first and the U are equal here, if they extend true. If they do extend true, then just return true. You don't need to check anymore. Otherwise, you then check it on the rest of them. So this is, yeah, that's kind of interesting. Yeah, I mean, this is a great example of a recursive function that basically moves through the entire thing and iterates through it, and it works really well. The really crazy stuff, though, is happening inside my equal, where there's some like covariant, contravariant stuff happening. And in fact, Pretty has really made a mess of this. Like, yeah, if you look at all of this sort of generic stuff happening, I don't really want to analyze that because it's sort of like beyond my experience and my knowledge. But basically, this is a kind of thing that you could get from a library such as TS Toolbelt, and it sort of gives you a guarantee that the things that you're matching are exactly equal. So I guess what we were doing earlier, if we zoom all the way back, was basically sort of doing a similar tricky thing to that, which works quite well for primitive values and literals, but it doesn't work with, like, for instance, it thinks this is the same as this. It thinks that false not satisfy the constraint true. Oh yeah, because it thinks that, I guess, false is assignable to Boolean or something crazy. Yeah, anyway. That was hard. God damn, that was hard. But there we go. That's our warm-up. We're now going to have a look at something that I've been working on, which is something kind of dear to my heart, which is a TypeScript error translator. The idea here is that you can take any TypeScript error that you have, you can put it through a translator here, and it will spit out plain English, so you can understand what's happening. This is like, it's so cool that you can do this, and it really makes a big difference in terms of people's understanding and like their debugging. And I've got like an example error inside here. Let's actually just change this to like conversion of type number to type string, blah, blah. So it says submit your error, and it appears down the bottom. It's also a shareable link, by the way, so you can share this with anyone. So conversion of type number to type string may be a mistake because neither type sufficiently overlaps with the other. That's the original error. And the essential point here, the translation, is you can't use as to convert a number into a string. They don't share enough in common. And like, that's just so much easier to read. Like this, what can happen here, the way this can be produced, is if I just take in another little file here, is you can say const whatever str, let's say it's a number, or in fact, no, we're gonna make it a string. So we'll say hello world. And then the way you get this error is you say as number. And so you get this full on error here. And if we just take this and copy and paste it, then stick it up here and we get the same thing. Pretty cool. Diogo, yeah, I tried these challenges a week ago and even the easy ones were hard for me. Yeah, I think some of them are not sorted correctly. So some of them are pretty easy and some of them are really, really hard. So I don't blame you, actually. I'm looking forward to, when I release my course, making some type challenges that are a bit more graded, a little bit easier. I'm just going to do some little bit of Twitter admin, see what's going on. Who's here? Hello, hello. All right, cool. I'm so hyped that you guys are here. It's so guys and gals are here. So yeah, if you've got any Twitter challenges or any sort of translation that you want to do, then this is the place. So let's now look at, I wanted to make some content about a really, really crazy bit of code that Anurag Hazra from Twitter came up with. And this is a bubble sort algorithm. And it's all in TypeScript. And we're going to just sort of like try and make sense of this code and see what it's doing. And we might not figure out the whole thing, but we're just going to figure out the basics and like some of the tricks that he's using. So, all right, from a top level, we have a bubble sort kind of generic function here. What it's doing is it's a type, and it takes in a single generic. It looks like, yeah, a single generic, and there's a trick here that we'll get to later. But you can think of the public API of this bubble sort as just like it's essentially only one generic. So I'm actually going to mark this with a underscore and current, because you notice all the places that it's used, it's only ever you pass in one generic. And the way this works is we have a demo here. You can see that it's all done amazingly, like it's 1 to 9, all in TypeScript. So let's have a look at how he does it. There's also, by the way, a namespace sort of utilities library, which I think we're probably going to have a look at first. So I'm going to remove this bubble sort here. And what this does is there's some really interesting stuff here that's allows you to compare the values of two numbers, which is something that you can't usually do in TypeScript. So let's have a look at this first. So what we have is, like, you can't do things like this in TypeScript. Let's say you have a type maths equals a is greater, or 1 is greater than 2, like do something, true, false. This just isn't valid TypeScript syntax. You can't do anything like that. So what you need to do is you need to basically write that stuff yourself. And the way that Anurag has chosen to do this is via by turning those numbers into tuples with the length of the number. So they're called n tuples here, basically. So let's see. So let's say we have a type my number equals n tuple, or m.n tuple. What can I? Oh, I've got to export this first. This is from within namespace, so you only sort of. It's kind of cool. It's like a type class, basically. So only the things you export are the kind of public members of that class. So m.n tuple, and then what you can do is you can say 12, let's say, and it will create a tuple of length 12. So if I change that to 3, then we have 3 members of that tuple. Very cool. You can then get the length of that tuple. So let's say length here, n tuple, or sorry, m.length, and it will return 3. So this is a really cool trick. You can actually, TypeScript doesn't give you a way to have a, how do you say it? It doesn't give you a way of like comparing numbers, but you can represent that number as the length of a tuple, and you can turn a number into a tuple, and then you can turn a tuple into a number by this sort of crazy trick here. So you have my number is m.length, m.n tuple. And then the other idea is you can use this then to just push members to that array to increase the number or subtract the number. So let's say we want to add 2 numbers together. What you end up with, type, let's say 1 equals 1, type 2 equals 2, type 3 equals m.add 1, 2. And this turns out to be 3. Crazy, super crazy. I wonder if you could do this with like multiplication or things like that. And you notice that the add is actually really simple. It's just you take that n tuple and you spread it in to a new array and you get the length of it. So once you understand the plumbing, like it starts to make sense. So here's a subtract one here. And n tuple a extends infer u. Okay. So there's some cool inference here. So what's going on is we're basically creating an n tuple out of the number. And what we're then doing is we're saying if it's, so this is cool because you can't subtract something that's bigger than something else actually. So if we try and subtract like, we can't go into minus numbers here. So we can say type minus number equals m.subtract or m.sub. We're going to sub 4 from 1. If that's going to work. No, it's the other way around. So it's 4 minus 1, so it's 4 minus 5, let's say. And this is going to be never. The reason this is never, I wonder if you can do this. Yeah, you can do 0. The reason that's never is because it's basically inferring, it infers the length of the second tuple there. So it's basically saying, okay, is this an array of like 4 members of any? And then it infers the top here. So it's basically, you've got an array of like 5 members, and then you take the 4 off the end, and then have just 1 left over, and then you get the length of it. So that's how you subtract. Super crazy. So that's the sub. Finally, you've got the comparator. So what this does, n1 extends n2, false. So cool. So this is like, you first of all compare if 1 is assignable to 2, so if they're equal, and if they're not equal, then return false. Otherwise, you subtract, and this is like exactly what we were just talking about. You first of all check if it's a minus number. So if it's a minus number, the like subtracted, so okay, let's say this is like 4 and 2. So in theory here, what you should be doing is you should be like comparing 2 to 4, and I'm trying to work out like whether it returns true in that case. I think comparator, what it's doing is like is greater than, so is 2 greater than 4? Obviously n extends 2, so if they're equal, return false. So I'm going to comment this. If equal, return false. If 4 minus 2 is less than 0, return true. Or rather, let's just go if n2 minus n1 is less than 0, return true. Otherwise, return false. Such crazy stuff. So let's see, I wonder why that is inside. I think this is like inside a tuple, just so it doesn't expand. Yeah, I'd need to check why that is like that. Otherwise, return false. Okay, so just going to check if that makes sense. So you're checking if 2. So if this was 1, and then y going to 0. Yeah, you're basically checking if the second member is greater than the first member. That's when you'll return true. Very cool. So now that we understand that, we can now see that a lot of this algorithm is basically just like array stuff and like spreading things into an array. And let's actually just walk through one by one. So current extends 1. Yeah. So this trick up here, this underscore current, is basically a way of saving a local variable, and it's basically saying, yeah, this is basically m dot, yeah, we can replace this with m dot length a here, I'm pretty sure. Check if that doesn't break anything. No, all good. So this is the current length of the array that we're in. If we're in the yeah, if the current length of the array is 1, let's comment this as we go. If we're at the first member of the array, we're done. Thank you. Otherwise, we're going to have the first element of the bit of the array we're on and the second element of the bit. So let's just rename these. First lm and second lm. And then we've got the rest of the array down there. So if that's true, then we bubble sort them. Yeah, okay, that's supposed to be never not true, which makes sense. So we've got that there. Then the bubble sort. Wow, this gets really crazy. Okay, so this is the first condition here, essentially. We're checking if the second lm is like higher than the first lm. And if that's true, then we put the second lm first. Otherwise, we put the first lm first. God, that's just crazy. Oh, it's so crazy. And then we bubble sort the rest of it. So you can, like inside your own type, you can reference the type again and then just roll through again. And then why is... Yeah, I see. And the reason m sub is here is because every time we process a member of the array, we need to reduce the current number. So, oh, if we're at the last member of the array, we're done. Because it's not current, actually. This is like the number of elements left to process. There we go. So we basically call bubble sort again, but this time we override the number of elements that are left to process. God, that's so cool. Just so cool. And so where does the first element go here? Yeah, first element. Oh. Yeah, you get the idea. This is some amazing stuff. And I'm so glad I got the chance to look at it and have a play with it. This just feels so amazing. All right. Well, I can feel my tummy rumbling. This was a lovely stream. Thank you so much for joining along. Well, I think I'll be doing more of this soon. This just seems really, really fun and a great opportunity to talk to people. And other than that, I will see you folks on Twitter. I'm at mpocock1 on Twitter. Let me just see my Twitter here. Here we go. Hello. And I've also got a course that's coming out called Advanced TypeScript, where you can become a TypeScript wizard. We're going to be looking at some of this stuff more in depth and in a more structured way. So we're going to go from the basics, or sort of the semi-basics, like you should be able to know kind of the sort of beginner intermediate stuff. And we're then going to move on to the more complicated generics, conditional types, all this crazy business that you see before you today and that we've had a very, very brief look at. So yeah, do let me know on Twitter what you thought, subscribe on YouTube, and I'm looking forward to seeing you guys again.